Okay, so in this video we're going to do two problems. The first example, we did one similar to this, but we used completing the square. So we're going to find the inverse of a quadratic, but we're going to use the quadratic formula. And so this is another method to work with a quadratic, and the reason that we can't use just the simple idea of switching x and y is because we have an x here and an x here. We have two written x's, which makes it a little bit more difficult to solve. So we're going to walk through the process of how I could use the quadratic formula, which I have up here. Okay, so our first step is anytime we find an inverse, we're going to go ahead and switch our x and our y. And notice right here, this is where c would be, but I don't have anything there. So a is equal to 1, b is equal to -2, and c is equal to some value, right? So the key is when we use the quadratic formula, we do it by solving a quadratic set equal to 0. So I want to set this equal to 0. So what I do is I move the x to the other side. So I'm going to go ahead and do that, and I'd have y squared minus 2y minus x. So c is -x. Okay, so I'm going to start working this problem now that I've kind of set it up here. I'm going to start solving this problem where 0 is equal to y squared minus 2y minus x. And this guy right here should be a y. Sorry about that. So now let's use the quadratic formula. And these are all my values for the quadratic formula. So I have a -b. So -b, so opposite of 2 is 2 plus or minus the square root, and -2 squared is 4, minus 4 times a times c, which is a -x, all divided by 2 times a, and a is 1. This is equal to y. So now I'm just going to go ahead and simplify what I have in the radical. So I have 2 plus or minus the square root of 4, and if I distribute this guy, I got to do that first because it's multiplication. So -4 times 1 times a -x is a positive 4x, all divided by 2. So now the other piece here is simplifying. So now with this simplifying, I have 2. Both of these guys have a 4, so I can pull a 4 out. So it's really 4 times 1 plus x. Well, what's the square root of 4? 2. And we're going to go ahead and reduce because these three numbers all have a 2 in common. I can reduce, and that leaves me with 1 plus or minus the square root of 1 plus x is equal to y. And that's our inverse function. Now, one of the keys here is when b is an even number, I'm using this as an example, but when b is an even number, the completing the square method probably is a little bit easier, but if you like this method, it'll work no matter what. You just got to remember to simplify if you have a perfect square. So now I'm going to do another example, but we're going to have a value for b that's odd, and I'm actually going to throw another number in there just to change a little bit of the level of difficulty of the problem. Okay, so here we go. We have our quadratic. We want to find the inverse. Here is our quadratic formula that we're going to use. So I'm going to switch x and y. And the goal is to set this guy equal to 0, so I need to move the x over. So as of right now, c is going to include 7. Okay, so now we have this constant in here, so how does that change our problem? We really just include this with c. So I'm going to go ahead, and 0 is equal to y squared plus 5y plus 7 minus x. So this guy right here is c. So a is equal to 1, b is equal to 5, and c is equal to 7 minus x. So I'm going to plug all that information into the quadratic formula. So I have negative 5 plus or minus the square root of 25 squared minus 4 times a times c, which is 7 minus x. And look what's nice. This whole thing is equal to y, and now we just have the 1x in our quadratic, and we just need to put together what's inside the radical, and we're done. And we have 2 at the bottom. So this is going to equal negative 5 plus or minus the square root of, let me erase this if I can. This guy should just be 25. 25 minus, and we're going to have negative 4 times 7 and negative 4 times a negative x. So negative 4 times 7 is a negative 28, and then we have negative 4 times negative x is a positive 4x. So be careful with your distribution, all over 2. I'm going to simplify what I have inside, and I have negative 3 plus 4x, all divided by 2. Nothing on the inside can reduce, so that is our final answer, and that's what y is equal to. So the key here is just setting the equation equal to 0, and something with x or just x by itself is going to be your c value, and then just simplify what's inside the radical. So this could be a very efficient method for finding an inverse, whether you have a b value that's odd or even. So if you don't like the other format of completing the square, you could use this every single time, and it's a perfect way to find inverses of quadratics.